Upon one of the last things I mentioned was upon fertilization that only one's going to win, right? It's only one sperm is going to fertilize the egg. This just kind of shows you. Remember, I said that there's a first polar body division where that secondary oocyte starts to divide, and it creates a polar body, right? And then what will happen is immediately at this stage right here, when you have sperm entry, notice these centrioles start to form, sort of like spider webs that reach out and grab these chromosomes and start to pull them apart again. And you're going to trigger another cellular division right here. This is going to be, it's going to result in another polar body. There's the first polar body. There's going to be another one that's going to come out because of this. And that's just to rid itself of genetic material, because right now we still would have too many chromosomes if that were the case. Okay, there's a whole lot of biochemistry that happens right in this area that we're not going into in terms of the pathways that are triggered to prevent additional sperm fertilizing this egg. It's kind of neat. There's a lot of calcium involved. There's other things involved that will sort of shut this whole thing down and keep the other things, keep the remainder of the sperm from coming in. So it actually digests its way in. At this point, the midpiece and the tail is got where it needs to go. This acrosomal layer on the outside, this protective and enzyme layer on the outside, will start to digest its way through. The goal, of course, is just to deliver the package of chromosome, of genetic material, to the inside so that it can fuse with the genetic material that's already there. Okay, now this is some neat ground to tread on ethically. Okay, so I want to make sure we understand this. As far as fertilization, from the point of fertilization to the point of birth itself, we know that there's a lot that happens, but what is largely not understood is, let's say, anywhere from the first 5 weeks through after fertilization. I'll just lump it all together there. We know that fertilization is going to take place somewhere up in here, in this upper third of this tube. Now, when fertilization takes place, I guess, I'm not going to try to have a philosophical debate in here, but just keep a couple things in mind, okay, as you think through your positions on things and your general understanding of the human body and the world itself. Is a human egg cell a human being? You don't have to answer, just think about it. If it is a human being, then that changes a lot of things as to how we have to think about it. If you are picking fertilization as your point of when you think human life begins, just because it's convenient to do so, it seems like a good starting point. You've also got a lot to consider, because there's a lot of substantiation that goes into that claim. Okay? If you're saying that right here, this person forms because fertilization happened and you have a new genetic combination that heretofore never existed, right? Okay, is this a being? Is this a human life at this point? I'm not saying it is or isn't. I'm not trying to take a position. I'm just saying ask yourself this question. Because if you make a claim that it is or is not, I also want to consider everything that's going to happen after this, all the things that could happen to that, all the things that we do on a daily basis to affect that, and it may challenge. It may make you be not so confident in your decision one way or the other. It's a very gray area. When you get into situations like this, I know that at first it seems very black and white. And it seems like it's easy to take a stance on this kind of stuff. But the more you learn about science, and the more you learn about just general philosophy, ways of thinking, whether it's religious philosophy, whether it's just logic, whatever it is that you pursue in that realm, you will see that the more you learn, the more you realize that things just aren't black and white. They just can't. I'm coming at this from two different angles. Okay, right? My doctoral work is in religious studies and bioethics, things like that. My graduate degrees are in the hard sciences. So I'm coming at this from two different angles. So believe me when I say that coming at it from both angles, it is not as easy as you want to make it. Okay. All right. Now, when this happens, we've got a fertilized egg now that we call a zygote. Now the bulk of all this material is egg cell material. It's the ovum. The only thing that's there because of the sperm is the chromosomal number. Okay? So is it possible to induce an egg? Is it possible to cause an egg to divide, continue dividing mitotically, as opposed to this final meiotic division right before the sperm came in? Is it possible for that egg to divide, or is that egg just now still, that cell still a part of that woman and one of her bodily cells? Because it is possible to cause an egg to divide mitotically and produce a clone of that mother. We know that in other animals it is perfectly capable. I told you that reptiles do it all the time. There are cases when eggs can undergo parthenogenesis and can start to divide. Now, if that egg, now in humans it doesn't happen, although there's definitely, I'm sure at some point there'll be a way to figure out a way to program that egg to start dividing. And if that egg starts dividing and can start developing into a ball of cells, and it ends up being basically a twin of the mother, although, obviously many years later, right? I mean, realize clones exist all around us. They're identical twins. That doesn't mean they're the same person, same being. That just means their genetic material is the same. So does that change your idea as to whether or not that egg is life itself at that point? If fertilization is not required, is that egg a separate being? Or is it just an extension of the mother? And at what point does it stop becoming an extension of the mother? How many cells have to divide? Does a limb have to form? How do you know when a limb forms and when versus a bud versus a group of cells that are becoming differentiated to become into a limb? You can see the problems with this. Okay. So assuming things stay the way they are and set up like this, fertilization happens, and see, that's a convenient point people like to pick to say, okay, life starts there. Maybe so. Certainly, biological processes kick in big time, and you get a group of cells that are highly specialized and working together. But we have that all over our body as well, in tissues and organs and things like that. Now, I'm not taking a side. I'm just stating some facts here. Now, as this thing starts to, these cells start to mitotically divide and sort of cleave apart from each other, they continue to do so for several days until you've got this ball of cells. Now, I want to point out something that's very important. If you think, and again, I'm not saying you're wrong. I'm just saying if your stance is, this is certainly a being that is alive. Okay, if that's true, let me point out something. I could take this ball of cells right here. I could separate those four out from each other, and each one of those would continue to develop as four separate beings. These are completely, in the purest form of stem cells. These are embryonic stem cells. I could take these apart, each one of them separately, let them float around, and they'll all start making one of these balls themselves. And they'll have, what do you call the four? If there was five on quintuplets, quadruplets, you would have quadruplets then, if you busted that up, right? If it separated, if these two were dividing and it separated apart and got into two, that's identical twins, right? If it would have separated into three of those, you would have had triplets. Okay? So it's very gray now at the point of, where does one life separate out? How did you get three lives out of one life? See what I mean? If you're at that point and you're saying that this is a live being, which I'm not saying that it is or isn't, but if that has the potential to separate out into three separate beings, that's gray. That's completely confusing. No longer can you stand on that fact that fertilization must be the answer. You can do whatever you want, but I'm saying logically speaking, it's hard to still maintain that stance. Okay, now as we continue to develop, what makes it even more difficult is the fact that we do not know. There's no way of knowing. We can't get down and latch ourselves on and anchor our physical beings onto this little ball of cells and watch what's happening and interpret the codes that it is receiving, that they are receiving. Because what these cells start to do is they start to specialize. After this ball of cells gets big enough, this initial ball of cells right here, when it starts to get big and sort of packed around, in about 3 to 4 days, you've got what's called a morgula. Okay? It's a big ball of cells that probably at this point are largely undifferentiated. So in other words, you could pull a lot of these guys off. Some of them might have already been to specializing. Some of them might have already started to go towards types of cells that would be connective tissue or types of cells that would do something else. But a lot of them are still going to be largely undifferentiated. They can turn into anything. So you could start busting all of these up and separating out and getting new life as well, if you wanted to. Some of them probably. But there comes a point, and you can't pinpoint it. It's a gradual transition where these things start to receive a more specific signal. And they start to interpret the signals that they have, and each cell starts to produce a little bit different protein until they start to become specialized and are going to start growing specific types of tissue. Okay? Again, the mechanism by which we don't understand all of it. And we never will so long as stem cell research is prohibited, right? And if we don't have access to this, we're never going to learn how this process happens. And some of you might say, well, good, we don't need to. Well, that's one opinion, I suppose. As we continue to develop, what happens is that ball of cells sort of indents on itself. Imagine taking like a Jell-O ball and pushing in with your finger on one end and making a little dip in a cavity, and then pulling around the other end and closing up that to make a hole in the center. That's what happens to these cells to create what's called a blastocyst with like an opening on the inside. We have body cavities inside of us, and it all comes about because of this initial hollowness that starts here. So now we've got this hollow ball of cells. And that's all we are by the time we hit down here. Okay? We are a group of dividing cells that is increasing in specialization. And there's no way of knowing. We don't have limbs and feet and hair as we come out of this thing. There's no little cells here that start sprouting little flagella that ends up being hair or anything like that. Or it doesn't work that way. We're just a ball of cells. And we land somewhere. And when we land somewhere, we start communicating with the cells that are around us. In another case, the womb, right? The uterine cells. We start creating junctions and growing more tissue into that tissue, eventually becoming a placenta, and it all merges together. It remains separate, but it merges together. This is completely fuzzy. It's completely gray. Everything is just sort of all mixed around when this happens. But it is very interesting that, you could technically, like I said, take any of these cells and create separate human beings. Now, the idea behind this, there's a lot of sort of sci-fi kind of stuff you could think about that actually is no longer just sci-fi, but becoming more reality. Is it murder to take off one of these cells? If you have a ball of cells, and they all have the ability to massively produce and make more copies of themselves, and they're completely totipotent. They can turn into anything. Now, they're stem cells in every sense of the word at this point. And you take off one to test it, have you killed a being? Because that cell itself, if you left it by itself, could grow into another human. Have you killed someone by pulling off one cell? And when do we start separating single individual cells as being separate from the body versus being part of the body? You can see what I mean. Okay, there's a lot to think about. But certainly if we split these up, this is what's happening with some of these banks that are frozen. You think about frozen embryos and that kind of stuff, and the things that are going around and some of the controversial issues of the time. But, there are embryos out there that are arrested in this stage of development because there's no legal documentation saying that they are or are not alive. They're just in that gray area where there's no one, no matter what you do, is going to be able. Now, there's guys out there trying to define it, based upon their own position, trying to define somehow, get a good legal definition of what's going on here. But as you can imagine, politicians who are lawmakers know very little about biochemistry of what's happening here. So they're relying on other people to tell them how it works, and they still don't understand how it works. And the people who are telling them are going to bring an agenda as well, depending on who they represent, right? So this is a great place where science and politics start to mix together. But anyways, there are places around right now where, things are arrested in this stage of development, any of these up here that you see, because maybe they are people, maybe they aren't. But if they are, well, they're frozen in a freezer somewhere. If they aren't, then there's just cells that have the ability to heal, to replace parts, to do other things that are sitting out there. It depends on how you want to look at it. Because if stem cell research is furthered and more money is given to it, and the scientists are allowed to experiment on this and figure out some of this programming code that goes into this differentiation, you can imagine that if we had these types of cells, we've got a lot of power to fix people, to cure diseases, to replace cells based upon taking the original ones and programming them to grow into certain types of tissue, things like that. It depends. My hope for not only my students, but the people that I know, whether it's people from the non-science side, whether people from the science side, or people in between, I just hope that no matter what, when you're approached with issues like this, that are hard issues, most of the time you don't want to think about them. You just want to form your opinion, be blissfully ignorant, and move on. Okay? But that's, like Socrates says, the unexamined life is not worth living. If you're going to walk around in a stupor and pretend like things aren't happening, then you're not experiencing true reality. Okay? If you're going to form an opinion on this stuff, make it an educated opinion. Don't just hear what you want to hear. Hear everything. Because you don't want to believe something that you can't support and that you can't provide some sort of defense for, no matter what it is that you choose to believe. Okay? That's all I'll say. I just want you to be educated. I want you to realize that things are not as simple as they appear. And it takes some thought. And a lot of people are thinking about it. But the problem is a lot of people don't want to think about it. So when you got people who are thinking about it and people who are not thinking about it, you got this. Because these people think these people are stupid. These people think these people are arrogant and stupid. When the problem is no one's right here. There's a lot of people right here, don't get me wrong. But they're not the ones making all the noise. Okay? A lot of the people who make the noise are the extremists on both ends. That's who's going around causing these fights. Mainstream America, if you look at a normal person who understands the basics of what is this, you're going to find somewhere in the middle. It may not be exactly in the middle. They may lean one side or the other, but they're never going to be on a polar end of what's going on here. You're going to get that with a lot of science and religious or political issues. You're going to find that. Okay? There's an easy way to be moderate and meld it all together. But anyways, get off my soapbox. So what about birth control? Is birth control murder? Ooh, don't want to hear this, because depending on what kind of birth control you're using, and then you consider that, and dependent upon what your state and definition of where life begins, maybe it is, maybe it isn't. And if you want to change your definition of when life begins to support your decisions that you have made in terms of birth control, then that's a poor reason to change positions. You need to come up with a definition that works for you. But let's take a look. Starting down here, I'm going to work my way from here all the way around and get up here and talk about the different. Now, this is not all the types of birth control, but we'll look at how it affects particularly what is going on. Okay, these are just the common ones. Obviously, down here at the beginning, you've got coitus interruptus, the fancy way of saying pulling out. Okay. Obviously, that there's no way of preventing. There is no way of preventing sperm deposition. If as long as there's contact there, there's certainly capability of cellular exchange. There's also chemicals, right, that are designed to deactivate those cells. Spermicides and things like that. There are physical barriers, whether it's male or female, depending on what is used. The point of this, of course, is just to act way down here and just prevent migration of the sperm in general. Okay, as we get over to here, and we act upon the ovaries. Well, I guess I forgot this one up here. Sterilization, obviously, in the case of the female. The picture changes a bit for the male, right? But in the case, obviously, you can have tubal ligation. You can have the tubes tied, right? That's obviously should prevent sterilization. Should prevent fertilization, just by virtue of the fact that you've eliminated the path through which this can travel. We all know that's not 100%. I'm sure we've heard stories about how that backfires sometimes. But anyways, further down, so here we've sort of just physically prevented things. Here's a chemical prevention, but most of it just physically prevented things from getting to where they need to go. Now we've got working here at this level, at the level of ovulation and the level of the ovaries. What are some alternatives that are there? There's natural birth control. If you know what I've taught, what we talked about, hormonal fluctuations, and each person's a little bit different, but you could monitor. We said that with estrogen and progesterone secretions, cervical mucus can change levels, temperature can change levels, general mood. I've not experienced it obviously, but I'm sure there's physiological indicators, right, that accompany this. Those two being the biggest. Natural birth control is certainly an alternative, especially if you understand your body and if you understand the science behind what we've talked about. There's a safe period there, right? Especially right at the beginning of the cycle, before anything has been released, before ovulation has happened, before the egg is even out there. But like I said, keep in mind that sperm can live, say anywhere from 3 to 5 days, but up to like a week sometimes in the tract. So you want to take yourself away, so you're limited to about a first week there, where it's sort of actually kind of the safest you can get. But certainly, if you can keep track of that cycle, then natural is one way to go. Oral, the pill, whatever. Now the purpose of like orthotricycline and those kind of things, the actual birth control pill, the purpose of those is to still give you, that's why it's dosed, right? That's why you have specific days that you have to take, because you still have to give yourself the estrogen and progesterone in cyclical fashion. That's why you got specific days to take, because you've got to increase it and you've got to decrease it just like the body normally would. But the difference is, what these pills allow are for you to still personally and physically control your hormonal levels by taking those on the prescribed times, all the while not allowing and suppressing gonadotropin-releasing hormone. Now, why is that important? Because if you suppress gonadotropin-releasing hormone, you're going to suppress estrogen, right, and all that kind of stuff, but that's okay because you're taking it. What you have not taken anything for, which you are trying to suppress, are your FSH and LH, the things that are going to contribute to follicle stimulation and follicle formation. So basically it prevents ovulation is what's going to happen, because if elevated levels of follicular hormone is not in there, you're not going to form follicles, there's not going to be that trigger, that hormonal trigger, and they're not going to be, in theory, not going to be ovulation either. So you can physically prevent ovulation, hormonally prevent ovulation. But you have to take them, in the fashion that you do, because that estrogen and progesterone still need to be there. Okay, and since you're suppressing this hormone that controls those, you've got to be able to put those in yourself. So there's no follicle development. One of the effects, of course, is increased cervical mucus if this is the alternative to choose. There's also the subcutaneous progesterone implant that sort of works the same way. It's a matter of acting on gonadotropin-releasing hormone, preventing it from being released so that follicular development doesn't occur. Okay, now moving up, let's say post-ovulation. Let's say that we're over here. Now this is where it gets ethically gray. Okay, anything but I'm not saying these aren't. I'm not saying that these are right or wrong. I'm just saying this is where the big questions come into play over here. Let's take an IUD, for example, intrauterine device. It's actually something that's a metal, usually a copper-based alloy, that is actually implanted into the uterine wall. Not entirely understood as to how this works. What seems to be the case is it induces an inflammatory response and irritates the uterine lining so that an egg, even if it's fertilized, that's the problem. Even if it's fertilized, cannot attach because the cells will make it, the uterine cells will induce its own immune response. The body will do that and prevent it from doing so. Whatever's happening cellularly, try to respond to this device doesn't promote bonding to the uterus. So the question is, how ethical of an approach is that? It depends on your perspective, because if you think that a fertilized egg, thus a zygote, and a morula and a blastula, if you don't think those are living beings, then it's no problem to prevent it from attaching. Some people will say life only begins when this implants itself and pregnancy occurs. But at the same time, I could take that and put it in a petri dish, and I could implant it in another woman or whatever. So once I pull it out of the body, is it still alive or is it not? I can't answer. The high-dose morning-after pills. Now, I'll mention something here. It says, depending on the progress of the cycle is going to determine how this high-dose morning-after pill is going to work. It can suppress ovulation. So that means if it's early enough in the cycle where ovulation hasn't happened yet, and it's a precaution, and you take this pill, you could keep ovulation from occurring. Okay, it can affect the hormone levels to do that. Or what will happen is if ovulation already happens, has already happened, and you've got a corpus luteum behind that's supposed to be secreting progesterone for pregnancy, it'll degenerate that. And if you degenerate the corpus luteum, you get rid of the progesterone levels, right? And the uterus now cannot be conducive to pregnancy, and it will not allow the developing embryo to attach. So now that's not that sounds easy. Realize that from what I understand, I don't have any personal experience with this, but talking with people who sort of do. From what I understand, this is not just like, you know that there's going to be, like there would be with menses, there would be not just, it's not like an egg is going to detach itself and fall out. That whole lining is going to come out as well, sort of like what a period would be. However, my understanding is that it's a little more traumatic than that. There's more to it than just like what a normal period would be. So, you've right at the verge of pregnancy, and then it just sort of stops. So we're dealing with a little bit something different here. And then of course we've got just abortion. This is actually what I just said about this actually applies more to RU486 down here. This is this kind of pill. So this could be. It depends on how far along it was and what you've done. But I'll talk about this in a second. Abortion, of course, is surgical removal of the embryo. Now we do have laws in our country that up to a certain time you can't remove that, but of course that's great because you after a certain point you can't remove it. That's great as well because depending on where you go and what other country you go to, you could go over somewhere else and have it done and come back here, and so there's loopholes around everything. But it's not an issue that's going to go away easily because it's way too big of a political issue, and it's out there in the political arena, and too many people can form opinions on it, and it's going to drive politics. So as long as it's going to be there. You got to be careful too. Just so you know, I know that we want to form opinions on this. We want to say it's a woman's right to choose, or it's never a right to kill a baby or embryo or whatever. And I understand that you think that's black and white. But realize that when you get up to the level of the Supreme Court, and say we overturn Roe versus Wade, and we say that abortions now are illegal, what you've got to realize is you set precedent at that level. And it's not just going to affect the people that you want it to affect, because there are always going to be situations where you wish that wasn't the case and that law did not apply, right? You cannot get one that's perfect. So you've got to ask yourself which is better, which would you prefer? And it's a matter of opinion. It's a matter of how would you like the law to actually read, how can it be interpreted, and whether or not you really want what you think you want, either way. Okay? Because, like I said, when you get into applications of this law and you get into court systems, you get into individual cases, there's going to be, if you mandate something that it's always legal, or you mandate that it's always illegal, or under these conditions, there's always going to be a loophole, and there's always going to be a situation where someone's going to end up getting the short end of the stick on this, okay, on either side. So there's no way that we're ever going to do this. And that doesn't mean we shouldn't try, of course. It just means that it's going to be incredibly difficult to do. Anyways, RU486 actually is pretty controversial, and rightfully so, because it is a chemical interference. It competes with progesterone receptors. The endometrium sloughs off and carries away the embryo. So you see what has to have happened at this point. Implantation would have occurred, okay? Because human chorionic gonadotropin is HCG. That's the hormone that is present that's what the pregnancy test, the p-test thing you take that it tests for, that particular hormone. If that is detected, and it's very, very early, or in the first couple weeks of pregnancy, you've just got a fresh implantation down here, RU486 can wipe that surface. It can compete with progesterone receptors, because remember, you've got a degenerating corpus luteum that is giving off progesterone, and you've got in your uterus, you've got receptors that are being responsive to that progesterone and changing accordingly, thickening, nourishing that environment to be conducive to pregnancy. Well, what this pill will do is provide a chemical that will go on and bind those receptors and lock it down, inactivate them, so that progesterone cannot further interact with them. So what's going to happen is that's going to halt that process. The endometrium is going to slough off and take with it the embryo that was stuck to it. Now that is definitely what I said about up here. That's going to be a lot. You've got an endometrium that's developed here, and you've got something coming out with that. So it's the discharge here that's going to come out. It's going to look a little bit different. Probably be a little more traumatic. Anyways, and I talk up here about future possibilities. There's some interesting research done about male birth control, about not just sterilization, but like pills that can inactivate, affect sperm motility, can inactivate sperm and that kind of thing. But that would work. It's probably easier, for the male body to have to deal with all that stuff. I know that's what all you're thinking. And maybe if you have a husband that you can stay on top of and make sure they're taking their pills or whatever, that's one thing. But just in the general public, to trust the man to do that, I don't know. I don't know if I would do that if I were you. But I think I'd much rather just be the one knowing and in charge, But that's not my problem. Okay, as far as how this placenta comes about, actually this blastocell, this hollow ball of cells here that hasn't even really fully differentiated yet, you can see where cellular division just kind of grows linearly out into and permeates and wedges itself between the tissue of what will be the baby and the mom out here. So this is ultimately going to be the placenta as it develops. It's actually, it's very rich in blood. It's very, very tissue thick, and it's completely sort of just webbed in with the mother and fetal tissue. It's all webbed together. So, it's not like it can just fall off. There's going to be blood loss here if you try to separate all of this. Okay, so you can see here where the capillaries become very rich and very thick so that it can deliver contents to all these cells, including fetal cells, as it is continuing to develop. So it continues to do so. It gets deeper and deeper. You'll know that here's the surface of the uterine lining. Notice the difference between the previous picture, how it's on the outside. What you'll find is as the cell implants itself and starts to divide, it actually almost gets underneath the endometrial lining. So, and then it sort of just goes from there. You can sort of read this on your own. This is stuff that we've already covered and talked about, but it talks about capillary proliferation and the growing more of these cellular fingers out through here and that kind of thing. So, now what is important, of course, is fetal and maternal blood are separated here by a thin chorionic layer that forms the placental villi. You will remain separate. Notice that there are no conjoining cells that make an open tube where you can shunt stuff back from one or the other. It is controlled across cell membranes. So fetal and maternal blood do not mix. Okay, you can have two different blood types for the mother and the baby. Now they can mix, of course, when the placenta starts to degrade and all this comes apart, and there may be minor tissue damage and that kind of stuff, and the blood all can start to mix together, and that could create some problems. We talked already about Rh positive in that situation. That's where you're going to see that if it ends up being an issue. But what's neat is this outside layer ends up forming the amniotic sac. And that's, you've got all this space in here. And then the ones that are right here start to proliferate inward and grow into that, and that's what's going to become the embryo. This is absolutely amazing if you ever get into this further. But anyways, anybody ever go to the, the museum in Chicago that had all the, it's the Museum of Science and Industry that had the stages of development all the way from the beginning to end. Very, very neat. Very neat. You should go. It's pretty cool. You can go up there if you've never been there. Lakeshore Drive in Chicago. You should take, if you got kids especially. It's pretty fun. There's a shed aquarium in the Field Museum. The Field Museum's got a lot of cool stuff for kids. This Museum of Science and Industry is cool, but it's more for people like me who want to read the stuff and see all the neat exhibits and stuff. There's more interaction at the Field Museum. Shed Aquarium is right next to it. It's all, you can park one and walk to all of them. Shed Aquarium is there. It's really nice. They got a neat thing at the bottom where you can. They have a dolphin and whale show and stuff. And it's right out on Lake Michigan. So when you're looking out the glass behind you, it's all the windows are glass and it looks like you're looking out into the ocean. So it's pretty cool. And then the planetarium is there. Adler Planetarium. It's right up here. So it's pretty neat up there. Then of course Soldier Field is not far away. I didn't know that. No, never been there. My brother lives in Chicago. I just mentioned a minute ago that HCG age. You know, it makes me think though. It makes me hungry now because I think of that coconut jumbo shrimp out back. Just like the movie, right? All right, HCG is human chorionic gonadotropin. I mentioned that. And what's interesting about this is that it only forms when implantation occurs. This is the basis of the pregnancy test. And that's why you can get a false negative, but you can't get a false positive, really, because, I mean, there's like 99.9% or whatever. A false positive would mean, a positive result means that this chemical was there, this hormone was there, and it interacted. A false negative could mean that it was there and just wasn't in high enough levels to indicate on the test. So keep that in mind. But there's a link here. If you want to see a little bit more, I'm not going to take you to it, but it's not showing you how to take a pregnancy test because that's not necessary. But it does show you sort of a little bit of the chemistry behind it and how that test that you use, like especially the one-line, two-line kind of test, that kind of thing, how that works. Get new test now. It's like you know, that's you've got mail. You know, like you pee on it, and ding, 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 you are pregnant. Send out a global email to everybody you know instantly. Anyways, now we know that it says that HCG is going to maintain the corpus luteum of pregnancy. Now, we didn't mention this before, but when that corpus luteum stays around to secrete progesterone, something helps it stay around. And what helps it stay around is once implantation occurs and HCG is circulated, it's going to interact with the corpus luteum to maintain it during pregnancy so that it's constantly going to be giving out some progesterone. So we know that estrogen stimulates the growth of the myometrium, which is the muscle layer, obviously, of the uterus, which is going to be obviously very important in terms of traction a little bit later. Strengthening it for parturition, which is delivery of the child. Progesterone levels actually suppress uterine contractions. Now, that's one way to prevent that from happening. And if mild contractions are occurring, one of the things that might happen is to increase the progesterone levels. So you know that's going to antagonize it. Relaxin is a hormone also that increases in concentration later on when the cervix starts to soften to get ready for delivery, to prepare for dilation, parturition. I'll tell you what, I guess it would just take a lot of practice. I don't know. But, you know, like the people who have kids, I guess. You go into the room there, and there's that chart over there that has the dilation chart, you know. You look at 10 centimeters, you're thinking, whoa. and you're but what I don't get is like, you know, and I guess experience, but, you know. No, but I mean, you go... The doctor comes in and they just, you know, they stick their hand in there and they say, oh, it's about 3 centimeters. I would definitely need like a ruler if I was going to measure that. You know what I mean? There's no way, you know. How do they just guess like that? How much practice does it take to get that right, you know? Yeah, but I mean, some people have bigger fingers than others.
That's right. Trust me, I
Oh,
know.
no. I'm just saying.
For the nurse in the room, it's the smallest hand. I was in the room with Natalie, and this one nurse, she came out like,
That's not where I intended on going with that one.
but that's a judgment call.
I know, but it's just, I don't know. They just seem so confident about it. What am I going to say? No, you're wrong. Let me double check, you know?
No, then they bring in somebody else to come in and make sure they're right.
They bring in a TV crew and all the interns. Oh, well. All right. Okay. Gestation, of course, is, gestation is cooking it, incubation. So it says overall the whole body system is going to respond to all the demands of increased gestation, everything that goes with that. Uterine enlargement, larger blood, larger amount of blood, you know, everything that goes along with that to sustain pregnancy. And this shows you the peak that exists in terms of human chorionic gonadotropin. Notice that within the first couple weeks or so, the levels are very low, and generally they are non-existent. But once you approach a few weeks, 3-4 weeks, whatever, or maybe even sooner, a couple weeks, it depends on how precise your test is, you're going to get a big surge of HCG in the body at that point. And that's why you can safely use that to test for whether or not pregnancy has occurred. And then you can see the progesterone and estrogen levels corresponding to that. Now, as far as parturition, that's the actual birth. We know that during the last trimester, the uterus becomes more excitable. It starts to become more responsive to its oxytocin receptors start to increase in number. It becomes more contractile. You know, the Braxton-Hicks contractions that can set in and that kind of stuff, the contractions before the actual contractions and all that. This is all strengthening and flexing and getting the uterus ready for parturition. Okay, the cervix begins to soften. The baby shifts downward, right? It puts its head towards the cervix, ultimately, hopefully, contacting the cervix. Rhythmic contractions begin at the onset of labor. This just sounds terrible. The rhythmic contractions begin at the onset of labor. They call it labor for a reason. There are high levels of estrogen at this time. Okay, so everything's gonna start to peak is what's gonna happen. And then what's going to happen is as soon as the baby's born, it sort of just all plummets. So you get a peak and a plummet in a very short amount of time. That explains some things. Just things. No. We had off camera, I'll tell you what we had in our room. All right. Just in case she watches it sometime. Now, this is what's interesting. What actually triggers parturition? What causes this contraction? What causes labor to actually begin? You would think that as much as it is studied, we know more about it, but we really don't. We know that oxytocin can induce it and chemically what can happen, but as far as what physiologically is controlling what's going on, it's actually a pretty unfamiliar area in terms of what we do know for sure. We know that oxytocin plays a key role as labor progresses, and to induce labor, you can give someone oxytocin, or synthetically we call it Pitocin. Okay? It's a powerful muscle stimulant, and it will increase the rate of these contractions. Also, something else that you wouldn't think would be related, but corticotropin-releasing hormone, one of the tropic level hormones that can induce the cortisol response. It's going to drive the manufacture of placental estrogen, promotes changes in the fetal lungs, all of sort of just like a stress response to get the fetus ready too. And this is a rare instance where we don't have a lot of positive feedback cycles in our body, but this is one where it certainly happens. Once oxytocin release starts, and this parturition begins, it feeds forward and it continues to compound and get stronger and stronger. Okay, more frequent, more powerful. And as the cervix, there's a direct relationship between as the cervix dilates, at the same rate oxytocin levels increase. So there's a tie-in there. Okay, so there's actually three identified stages of birth. They're real easy to remember. Okay, the first stage is cervical dilation, and you know it's about ready at this point. When now you could be one of those poor miserable individuals who get to 4 centimeters and you get there really fast, and then 6 centimeters, and all of a sudden you're at 6 centimeters for like 2 days, and then it just hangs around. Okay, but ultimately that's what we're trying to get to 10. So after the birth of the baby is the second. It says first stage is cervical dilation. Sorry, the second stage is birth. Okay, the actual delivery of the child. This occurs whenever your cervix is completely dilated. After the birth of the baby, a second series of contractions pushes out the afterbirth, which is the placenta and the other attached tissue. It separates the placenta from the myometrium, expels it through the vagina. That's the third stage. So we've got dilation, birth, and afterbirth. That would be the 3 stages of parturition. Okay. Now we know that after delivery, involution of the uterus occurs. It sort of goes back to it will come back. Okay. There's things that you can do to hasten the involution of that uterus. The continued release of oxytocin which will come about because of stimulation, actual tactile stimulation of the breast through breastfeeding. That can hasten involution of the uterus. Prior to, I want to mention a couple things about lactation. Prior to the loss of the placenta, before it's actually out, high estrogen secretion is going to make a lot of duct work in the breast tissue. Okay, it's going to start creating the channels through which milk can flow, and progesterone is going to start making the alveoli and the lobular regions that are going to surround these ducts and eventually work together to sort of pump and secrete milk. Okay? Prolactin is going to come in here as well. It's going to contribute to mammary gland development in general, the cells that are making the milk. So all these, this is actually before the placenta is even lost. Excuse me. Okay. And then after you lose the placenta, then obviously estrogen and progesterone levels are going to start dropping very quickly. An abrupt decline of estrogen and progesterone is what's going to actually trigger physiologically that lactation. Okay, now it may not be immediate, of course, but it's going to eventually trigger that lactation. So prolactin then is, at this point, up here it was just contributing to the development of the mammary glands. Now at this stage it actually promotes milk secretion. And oxytocin is going to induce milk ejection. You can click here to see an animation of sort of how stimulation, I think this might be that same cow picture that we used before, but that you can induce, you'll see what I mean if you get on there. I've used it before. It's a nursing calf, I think, on the mother. It's just a little animation. It'll show you that it can stimulate receptors that send afferent impulses up to the hypothalamus that will trigger the release of more oxytocin. Okay, so there's actually mechanoreceptors that are in the around the nipple that, when tactile, when it's stimulated, can cause afferent impulses to be sent to the central nervous system. And when it gets to the hypothalamus, it will cause and trigger the release of more oxytocin. And oxytocin will come down. It will help eject the milk. It will help also at the same time end up hastening the involution of the uterus as well. So, as far as breastfeeding goes, obviously there's advantages for the infant. Now, I don't know, just me, but a lot of, I'm not saying it's good, but I think a lot of things, you got to be careful about what you read. Some things play it up to be more than it is. I think that, not that it's not good, not important, but some of the research and some of the data that's going to be used to support these claims are a bit questionable in terms of how much of it has to do with just the mother herself, the type of person that she is, versus the act of breastfeeding alone. So there's a lot of variables that go into that. But nonetheless, there are certainly biological, physiological advantages if you can do it. An abundance of immune cells can be passed on from mother to baby. Antibodies, so a form of passive immunity, right? We talked about that in the past. Antibodies that have been preformed by the mother can be passed through breast milk into the baby. So there's some temporary immunity until the baby has enough time to sort of build its own active immunity. There's some nutrients that can pass through. Lactoferrin is a compound that can help reduce the risk of infection and that kind of stuff. So there's no doubt that there's benefit to it. But what I'm talking about is not necessarily health-wise, but like the statistics that you're going to read that say babies who are breastfed are smarter and that kind of stuff. You got to look at that a little skeptically, because you got to realize that what is their total environmental situation versus on average than babies maybe who are not breastfed, right? You got to look at the culture that they come from, the type of person their mother is, the type of socioeconomic standing that their family already has to be this concerned about breastfeeding to begin with. So there's a lot of variables that you would have to consider to ascertain the truth of that claim. Okay, let's see. Once you wean, of course, and the child is no longer breastfeeding, and this is another thing that I don't get, and I don't know if anybody does this, so I'm not. It's not that I'm against it; it's just I don't understand. When they're 4 or 5 years old, and they're still breastfeeding, and they come up and say, "Mommy, I'm hungry," I don't understand. Why a person, and I don't mean to offend anyone. I just don't understand. That's all. I mean, anyways. Well, whatever. I don't mean to start anything. I've not seen it. I've heard it. I've heard someone else talking about someone doing it. They got a pet name for their food source. Oh, like left or right, you mean? They just can't call it lefty and righty. But I don't know. Whatever. To each his own or her own or whatever. I'm just saying I don't understand it. Okay, now, once you stop, of course, then there's going to be a cessation of milk production. So, I mean, you got as long as you can keep it stimulated and keep it going, it'll go. That's what. That's the whole concept behind, like wet nurses and things like that. Someone could just keep that going and I suppose feed other people's babies. They did that, right? So, and then of course, suckling suppresses the menstrual cycle by inhibiting luteinizing hormone and FSH, thus preventing ovulation. Now, supposed to. The theory behind it is, and what is shown to definitely increase is by keeping, think about this, okay? Let's reason through this. If suckling continues, more milk is produced, right? Because, why? More oxytocin is being released. Remember, that's a negative feedback cycle. So if oxytocin levels remain high, it's going to continue to shut off FSH and LH because that feeds back to the hypothalamus that does gonadotropin-releasing hormone, and then gonadotropin-releasing hormone affects FSH and LH, right? Okay, so as long as oxytocin levels remain high, in theory, that should keep that hormone from being released, and thus ovulation should not occur. Now, we know, whether it's happened to you or whether you know somebody or just heard it before, you know that that's not always foolproof. That's not a good method of birth control, is to just assume that since you're breastfeeding, you're not going to get pregnant again, because that's just not true. Okay? Not that anybody has any experience with that, but okay. But there's the theory there. Okay. This is the ductwork. This is the enlargement that occurs is mostly because of this ductwork that forms in these specialized lobular areas that increase in terms of milk. The outside adipose layer is pretty much the same. Now, it can increase as well. I mean, why wouldn't it if in terms of you're increasing your food intake, probably increasing your fat intake and everything else, so you probably get some more there. But the bulk is this area right in here where that milk production area is taking place. So you have, this is kind of neat because oxytocin acts on these cells out here. Okay, these outside cells, they're sort of like, they're myoepithelial cells. They're a very thin layer of like epithelial cells, but they have the ability to contract. They have the ability to sort of all collectively communicate and sort of squeeze and use this as sort of like a medicine dropper top, right? Just kind of squirt this stuff out. Prolactin is going to work on these cells that are actually in here that are producing this milk and secreting it out into this area. And then, so you've got, that's why there's a difference between milk secretion and milk ejection. Prolactin is going to increase secretion, but unless there's something out here, just like oxytocin acted in the uterus to contract, it's going to do the same thing here. It'll help these things contract a little and expel the contents out. So we